The most important use of a shaft is to transmit the mechanical power from one device or a machine to another shaft as a drive shaft in a case of automobile. The propeller shaft of a ship, which one is a hollow, or an axle of the bicycle. The power is transmitted through the rotary motion of the shaft, and the amount of the power transmitted depends upon the magnitude of the torque and the speed of rotation that equal to omega. So we can very well calculate here the power. Power is simply equal to torque multiplied by omega. And we know that the omega is given as 2 pi n by 60. Omega is called as angular frequency, n is the rotational speed. In that case, we have power is equal to torque into omega is same as equal to 2 pi n. That is the rotational speed in revolutions per minute multiplied by the mean torque divided by 60. Sometimes you have to use the frequency which is given as omega divided by 2 pi. So omega here can be replaced as 2 times pi multiplied by f. So either we can calculate power using the 2 pi nt by 60, or we can calculate power as torque into omega, or we can calculate power as torque into 2 pi f, where f is a frequency normally expressed in hertz. So here we'll take some simple and basic numerical which is based on the value of power given to you. Once we know the power, we can calculate torque, and for torque in the case of solid shaft we can calculate the shear stress or the angle of the twist. Same thing we can do for the hollow shaft also. So basic numericals may be asked on the power transmission in the case of circular shaft. A hollow shaft is to transmit 250 kilowatt at a frequency of 30 Hz. Knowing that the shearing stresses must not exceed than 50 megapascal, design a shaft for which the ratio of the inner diameter to outer diameter, that is the value of K, is given as 0.75. So this time we have given the hollow shaft and we have power is equal to 250 kilowatt. We have frequency F is equal to 30 Hz. Allowable shear stress equal to 50, and value of K is 0.75 is d1 by d2. So here d2 represents the outer diameter, d1 represents the inner diameter. We have to calculate both value, and we have given here this data. First we use the formula for power to calculate a torque, and then we can use the second formula for torque, which is pi by 16 d2q into 1 minus k to the power 4 multiplied by tau allowable, and then we can calculate diameter d2. So these two formulae are useful for us. First we calculate here the torque, and then using torque we can calculate here the diameter d2. This time we have power is given as 250 kilowatt, so we have 250 into 10 to the power 3 is equal to 2 pi f, because frequency is known. So we have 2 pi and we have frequency equal to 30 multiplied by torque T. So we can very well solve here for torque T. This value of torque will come in Newton meter. So this answer is very close to 1326.3 Newton meter. Now to calculate the diameter d2, we'll use the formula for torque. We have torque is equal to 1326.3. So we have 1326.3. You have to use this value as Newton mm. So we'll multiply by 10 to the power 3 is equal to pi divided by 16 into d2. We have cube of it into 1 minus k. K is given as 0.75. So we have 0.75 to the power 4. Allowable shear stress is given as 50. Solve this, you will get diameter d2. This diameter d2 is close to 58.2 mm, and diameter d1 is 0.75 of outer diameter d2. So d2 is replaced as 58.2. We'll get d1 is equal to 43.65 mm. A steel shaft of 1.5 meter length, 48 mm diameter is to be used to transmit a 36 kilowatt between a motor and a machine tool. Knowing that G value is equal to 77 gigapascal, determine the lowest speed of rotation in the hertz, that is frequency you have to find out, at which the maximum stress will not exceed than 60 megapascal. So you have to take care that the maximum shear stress should not exceed than 60 megapascal and the angle of twist will not exceed than 2.5. So we'll model this as a solid shaft. We have given the length equal to 1.5 meter, diameter equal to 48, power transmitted equal to 36 kilowatt. Value of G is given as 77 into 10 to the power 3 megapascal. Tau allowable is equal to 60 megapascal. Angle of twist theta is equal to 2.5. That value you have to always use in radian. So multiply by pi divided by 180 is 0.0436 radian. We have to calculate here the torque. So one unknown we have to find out is torque. Second unknown you have to find out what is the frequency. Frequency we can find out once we know the value of torque. For that one we have formula for power is 2 pi f multiplied by t. Now we have given here the shear stress and theta. So for torque we have two formulas. For the solid shaft we have torque is equal to pi by 16 d cube multiplied by tau allowable. Diameter is known, tau allowable is known, so one value of torque we have to calculate. The second constraint is given as theta. So we know theta is equal to T into L by Jg. Using this also we can calculate here torque. So whichever is a smaller value that will govern the equation. So you have to select the minimum value given by equation 1 and equation 2. That will be the value of torque. Once we know the value of torque, we can calculate the frequency F because power is known to be 36 kilowatt. So let's start with the torsion formula. So we have torque is equal to pi by 16. So we have pi divided by 16. We have diameter D is equal to 48. So we have 48 cube multiplied by tau allowable. Tau allowable equal to 60. This answer will come in Newton mm. So one value of torque you will get from this equation is 1.303 into 10 to the power 6 is Newton mm. Now similarly we can use the twist theta equal to TL by Jg. We know the theta which is to be used in radian is equal to 0.0436 is equal to torque T. Your length is given as 1.5 meter. You have to use in mm is 1500 divided by pi by 32. So we have pi and 32 will come in numerator. Multiplied by d to the power 4. We have diameter equal to 48. So we have 48 to the power 4 multiplied by g, and the value of g is given as 77 into 10 to the power 3. Solve this equation. Here also we can find out the value of torque T. So torque T here come out to be 1.167, which one is minimum value as compared to the first equation is 10 to the power 6 Newton mm. So in this case the smaller torque will govern, that is the torque, shape torque will be equal to smaller torque. Dividing by 1000 you will get this answer equal to 1167. This one is the minimum value, so you have to always use the minimum value. Now the torque is final. Now once the torque is final we can use the equation of power. Power is given as 36 kilowatts, so we have 36 into 10 to the power 3, that will be watt, equal to 2 times pi multiplied by frequency F. Torque you have to use it Newton meter is 1167. Solve this to find out the value of F. You will get the value of F is equal to 4.91 Hertz. So you require a frequency of 4.91 Hertz. A steel pipe of 60 mm outer diameter is to be used to transmit a torque of 350 Newton meter without exceeding an allowable shearing stress of 12 megapascal. A series of 60 mm outer pipe diameter is available for use. Knowing that the wall thickness of the available pipe varies from 4 mm to 2 mm increment, means we have 4, then we have 6, then we have 8, then we have 10 mm thickness is available. Choose the lightest pipe that can be used. for the above purpose. So here we have given here the hollow pipe with the outer diameter, inner diameter is not known. So let's consider here we have a hollow pipe with the outer diameter equal to D2, inner diameter equal to D1, outer diameter D2 is equal to 60 mm, allowable shear stress equal to 12 megapascal, and the torque is equal to 350. The inner diameter we have to calculate, and inner diameter we can calculate from the knowledge of K, where K will be equal to D1 by D2. And the thickness T here is given as the outer diameter minus inner diameter divided by 2. For hollow pipe, the torque is given as pi by 16 d2q into 1 minus k to the power 4 multiplied by allowable shear stress. Here we will calculate the value of k. Once we know the value of k, we can calculate d1 and then we can calculate thickness, and after that we'll select here either we require thickness is 4, 6, 8 or 10 mm. So that is our step. So torque here will be equal to 350 Newton meter. So we have 350 into 10 to the power 3, that is Newton mm, is equal to pi divided by 16. Diameter D2 is 60. We have to make a cube of it into 1 minus k to the power 4. Allowable shear stress is equal to 12. Solve this equation and you will get the value of k is close to 0.56. This value of k is same as equal to d1 divided by d2. From this we can calculate d1, which is equal to 0.56 multiplied by d2, which is equal to 60. So we get here d1, that is the inner diameter equal to 44.83 mm. Standard thickness you have to select here. So we will calculate thickness first. We have thickness equal to d2 minus d1 divided by 2. That is equal to d2 is equal to 60 minus d1 equal to 44.83 divided by 2. So this value is exact answer is 7.57 mm. But 7.57 mm cannot be selected. So you have to select the next value equal to 8 mm. So for given transmission we require the thickness of the pipe is equal to 8 mm. Two shafts A and B are transmitting the same power. Shaft A is subjected to torque of 10 kN meter and 100 rpm. Shaft B is subjected to 150 rpm. The torque to which it should be subjected to torque in kilonewton meter you have to calculate. This time the power transmitted by A is same as equal to the power transmitted by B. Power is simply given as 2 pi into n multiplied by torque of A. So this one is speed of A divided by 60 is same as equal to 2 pi n B divided by 60 multiplied by torque of B. So 2 pi 60 cancel out. The torque of A is equal to 10 and speed is equal to 100. So we have 100 multiplied by 10. The speed of B is equal to 150 and the torque of B we have to calculate. So in this case you will get the value of torque B equal to 1000 divided by 150, which is very close to 6.67 will be kilo Newton meter. The diameter of the shaft A is twice the diameter of the shaft B. Both are made up of same material. Assuming both the shaft to rotate at the same speed, maximum power transmitted by B is same as that of A, half of A or 1/8 of A or 1/4 of A, that you have to find out. So in this case we have given here two shafts, shaft A and the shaft B. So let's collect the data here. The diameter of the shaft A is twice the diameter of the shaft B. So let's say here we have dA is representing equal to D. If this value is D, then the shaft diameter will be half for B. So dB will be equal to D by 2. So it is almost 2 times. Both are made up of same material. That is the value of tau max will be equal to tau. So in this case also we have tau max will be equal to tau. Assuming both the shaft rotate at the same speed. So we have Na is equal to N, then Nb is also equal to N. As far as power is considered, power is given as 2 pi into N divided by 60 multiplied by T. So N is remains same, so power is proportional to torque. Secondly, we have given the torque. Torque is equal to pi by 16 into d cube multiplied by tau max. Now both the shaft here has the same value of shear, so torque is proportional to d cube. Torque is proportional to d cube and power is proportional to T. It means that the power is proportional to d cube. And therefore we have power developed by B divided by power developed by A will be same as equal to diameter of B divided by diameter of A, and we have cube of it. In this case the power developed by B will be equal to dB, which is d by 2, and dA is equal to d. So this value is same as 1 by 2 and cube of it multiplied by power of A. So power developed by B will be equal to 1/8 of the power of A. Choice C correct? 1/8 of A. C is correct. A motor driving a solid circular steel shaft of 3 kilowatt power at 500 rpm. So power is known and the speed is known, so we can calculate here what is the value of torque developed. The diameter of the shaft is 40 and the maximum shear is calculated. So we have power is equal to 2 pi multiplied by N divided by 60 multiplied by torque T. We have power is equal to 40. So we have 40 kilowatt is 10 to the power 3 is equal to 2 pi into rotational speed N equal to 500 divided by 60 multiplied by torque T. So torque will be equal to 763 or almost 764 Newton meter. So solid shaft we have torque is equal to pi divided by 16 into diameter cube multiplied by maximum shear tau max. Maximum shear you have to find out. Torque is equal to 764. It's a Newton mm, so you have to multiply by 10 to the power 3 equal to pi by 16, and we have diameter is equal to 40, so we have 40 cube multiplied by tau max. So tau max will be very close to 60.8 will be megapascal. Gate numericals are very straightforward. A solid circular shaft is to transmit to a power of 20 kilowatt at 200. This is sufficient to calculate torque. Find the diameter of the shaft if the twist angle is one constraint, that is 2 degree in 2 meter length, and the shear stress is the second constraint, which is 65 megapascal. Value of G is given as 80 gigapascal. So we have power is equal to 20 kilowatt and the rotational speed equal to 200. Theta you have to always use in radian. It is 2 degree, it will be multiplied by pi divided by 180. So this value is close to 0.035, that will be radian. Then we have given the length equal to 2 meter, and the tau allowable will be equal to 65 megapascal, and the G value is also given, which one is 80 gigapascal. So first, using the power, we can calculate here torque. So we have power is equal to 2 pi into N into T divided by 60. Here we have power is equal to 20 kilowatt is 20,000 is equal to 2 pi. Rotational speed is 200 divided by 60 multiplied by torque T. So torque T is close to 955. I am giving you approximate answer, 955 Newton meter. Then second equation we have torque for solid shaft is equal to pi by 16 multiplied by d cube into tau max is equal to 955. So we have 955 into 10 to the power 3 equal to pi by 16. Diameter d is unknown and the maximum shear stress is equal to 65. Solve this, you will get one value of d. So here you get the diameter d is equal to 42.13 mm. But we are given the second constraint also of theta. So we have theta is equal to T into L by J into G. Using this also we can calculate one diameter. And for safer side we always use the larger diameter. Theta you have to use as 0.035. Torque you have to use in Newton mm is 955 into 10 to the power 3. Length is given as 2 meter, that will be equal to 2000 divided by polar moment of inertia is pi, 32 will shift in numerator, diameter to the power 4 and the G is given as 80. So we have 80 into 10 to the power 3. So this value will also give you one diameter and this value of D is equal to 51.37 mm. So this is one value and this one is second value. So for safe design always select the larger value. So for safe design D will be equal to D maximum, that will be equal to 51.37 mm. We'll take one problem from gate examination. A hollow shaft whose outer diameter is 2 times of inner diameter, where DO and DI represent the outer and inner diameter respectively, need to transmit 20 kilowatt at 3000 rpm. Maximum permissible stress equal to 30 megapascal. D0 you have to calculate. So K, which one is the ratio of inner diameter DI to outer diameter DO, is 1 by 2, that equal to 0.5 and we have power is equal to 20 kilowatt, speed is equal to 3000 and shear stress equal to 30 megapascal. So first using power we can calculate torque. So we have power is equal to 2 pi n multiplied by T divided by 60. Here power you have to use is 20 kilowatt is 20,000 equal to 2 pi. Rotational speed is given as 3000 multiplied by torque T divided by 60. So torque is come out to be 63.66, that will be Newton meter. We have given here a hollow shaft. For hollow shaft we have torque is equal to pi by 16 multiplied by DO cube into 1 minus K to the power 4 multiplied by tau allowable. Torque you have to use in Newton mm is 63.66 into 10 to the power 3 is equal to pi divided by 16. DO you have to find out, cube of it, 1 minus K, that is equal to 0.5 to the power 4. Allowable shear stress equal to 30. So straightforward, you can calculate here what is the value of diameter DO required. So in this case we required a diameter DO close to 22.6. The video you are watching is from the app, which is the Mohod class app available on Google Store, and in this app we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.